Today I'm going to introduce you to a term that you've heard floating around this unit, but we've never actually defined it for you. And we are going to talk about functions. We're just going to do a little mini introduction before you do your workshop activity today. And I'm going to use kind of an odd example to introduce to you exactly what a function is. I think a lot of us have probably been to those tourist destinations where you put a penny in the little machine and it like flattens it for you and turns it into some kind of a souvenir. Well, just in case you haven't seen one of those, I'm actually going to show you a quick YouTube video to make sure that we all know what we're talking about. Yes, it's kind of funny. This guy apparently just puts himself on YouTube going from place to place using these little penny smashing machines. But I want to make sure that we all know exactly what type of machine we're talking about. So let's pay attention. So, what on earth does that have to do with math? It's an example of a function. So, you have your little machine, the little penny smashing machine, and you have something that I know you guys have heard of before called input. Okay, that is actually what goes into the machine. Hopefully you guys noticed what he put into the machine. He put 2 quarters, and then, of course, the penny that was about to get smashed. So that is the input that goes into the machine. Then what comes out is called output. And, of course, it's just your little flat penny that comes out. So the input is what goes into the machine. The output is what comes out. In this case, it was 2 quarters and a penny goes in, and your little flat penny with some kind of design on it comes out. This is an example of a function. When you put in a certain type of input and you always get exactly, and this is the key right here, you always get exactly the same output. So I could go into that machine and right after that guy and put in 2 quarters and a penny. What's going to come out? Of course, a flattened penny. Somebody could come after me and put in 2 quarters and a penny. What's going to come out? Another flattened penny. So every time you put in the same input, I'm going to get the same output. If I put in 2 quarters and a penny, always, 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 from now until the day that machine breaks, I'm going to get a flattened penny. What on earth does that have to do with mathematics? Well, we also have our own type of functions with input and output. Let me use an equation as an example. So we've got y equals 2 times x. We're going to do a really simple one. This is an example of a function because if I put in the same input, I'm going to get out the same output every single time. Let me show you what I mean. So I bet you guys can probably take a guess. Now might be a good time to pause the video for a second and decide. So 2 is always 2. Okay, 2 never changes. But either this x or this y, one of them is going to be the input for the function, and one of them is going to be the output for the function. So either x or y, one is the input, and one is the output. Might be a good idea to pause the video for a second, see if you can decide as a class which one's going to be which, and then restart the video in just a moment. But I'm going to go ahead and go on and tell you that the input is the X. Because if you think about it, remember we've talked about independent variables, and we've talked about dependent variables. And we better remember that the dependent is the Y, and the independent is the X. The Y depends on what you put into it. So the output right here depends on what input you put into the function. So let's say, for example, that I decide that I want X to equal 4. So I'm going to put a 4 in to my function. 2 times 4 is 8. So that means that 4, 8 is one solution for that equation. Let's say I decide I want to put in a 4 again. Does it change? 2 times 4? Nope. Still 8. If I put in a 4, I'm still going to get out an 8. Well, let me try it again, because maybe it'll be different this time. Let me try to put a 4 in again. See, 2 times 4, nope. Still 8. So this is why it's a function. If I put exactly the same input in this case, if I always put in 4s, I'm always going to get out an 8. Well, let's try a different input. See if maybe it makes a difference if it's something different. So I'm going to put in a 3 for X this time. So 2 times 3 is 6. So one solution is 3, 6. Let's see. Well, maybe I'll put in a 3 again and it'll come out different. 2 times 3, nope, still 6. How many people think this is really silly? Let me try to do 3 again. Nope, still going to be 6. Well, this is the idea of what a function is. If I put exactly the same input in, I'm always going to get exactly the same output out. Just like our little penny machine guy. I can sit and put in 2 quarters and a penny as output all day long, and unless the thing breaks down, the output is always going to be a flattened penny. Let's say we wanted to try an experiment and see if we just put the penny into the machine. Forget the quarters. Say we saw that guy get his flattened penny. We're like, ooh, let's try to just put a penny in without. Are we going to get the flattened penny without paying the quarter? No, we're not. So actually, if our input, for that particular machine anyway, if our input were just a penny, we would get absolutely nothing out of the machine. So our input would be a penny. Our output would be nothing. Okay, let's say, so I try it and it doesn't work. So let's say somebody else comes up behind me and goes, oh, well maybe the machine just didn't like the looks of her. Now I'm going to put in just a penny and forget about the quarters. So I just put the penny in. What's going to come out? Still nothing. So again, it's still an example of a function. Because if I put the same input in this case just a penny without the quarters that the machine charges, I'm still going to get nothing out. So if I put in the same input, I'm going to get out the same output. So a lot of the time you will see the solutions to functions written just like this, just like a set of ordered pairs right here. And if you see just a set of ordered pairs like this that are just hanging out, you're going to find out the name for that in just a little bit in your workshop, which is a relation. And if you see a set of ordered pairs that are just hanging out like this, and all your x's are the same, and they're paired with all the same y's, well, then you can assume that this must be ordered pairs that belong to a function. So now let's take a look at this example. So again, we've got some solutions here, 3, 4, 3, 6, 3, 8. But, uh-oh, this time we've got the same x values, but they've got different y values. Okay, you can try all you want. You can sit here and try to think of equations all day long that might that maybe you could put in a 3 and get out a 4, then put in a 3 the next time and get out a 6, then put in a 3 the next time and get an 8, but that's impossible. Just like if I continuously put in 3's into this particular function, I'm always going to get 6's. If these ordered pairs came from a function, then if I have the same x values or the same input, then that means that it just makes common sense. I would have to have the same output as well. So it must be that these particular ordered pairs do not represent a function. I don't even need to know what the relationship between these 3 ordered pairs is. I just know that it's not a function because I've got the same input values here, but I don't have the same output values. So to sum up in our mini lesson, the definition of a function is if you have the same input going into it, you have to have the same output to go along with it. Now, sometimes you'll see ordered pairs that have different inputs. Notice these are all different. Your input is a 2, a 4, and a 6. Now, I don't have to sit here and try to think about what kind of function might result if I put in a 2 and I get out a 3, or I put in a 4 and I get out a 5. I put in a 6, I get out a 7. I don't have to sit here and think about it, although we could probably guess the function would be y equals x plus 1, because in every single case, if we take our x and add 1, we get our y. So that is actually the function that represents this. But we don't even really need to worry about what the function is. As long as we've got 3 different values in our input, we can just assume that, yes, this is a function. One last part of our mini lesson that I want to make sure that you guys know about is that, again, you know us pesky math people, how we love to give different names to the same stuff. So far for our x and y's, we've called them this unit independent variables, and we've called them dependent variables. We've called them input, and we've called them output. Okay, I'm also going to tell you about one more name. All your x values are also called the domain, and your y values are called the range. You are going to see this when you're doing your workshop today. When they say domain, and the definition will be in there for you again, domain refers to your x values, range refers to your y values. You can remember that because D comes in the alphabet before R for range, the same way that X comes in the alphabet before Y. So I think this gives you all the information that you are going to need. Remember, yes, this workshop is a little bit difficult. You've got to think, but you guys have noticed that there is all kinds of information throughout it to give you clues. So right now, don't get too stressed out. You're just making inferences and using your logical reasoning, and you'll do great.